This is how the ternary operator used to work under the old version of the language. That's the Java Language Spec Edition 2. If expression 1 and 2 were both reference types, then it had to be the case that one of the types had to be assignment compatible to the other, or you'd get a compiler error. What that means is that you've got a variable of one type and a variable of the other type. You have to be able to assign one variable to the other. That's what it means. The type of the resulting ternary expression was the type of the one which could be assigned to. So here's an example to illustrate that. You've got an interface I, and you've got a class C that implements it, and some variables like that. Then it's quite okay to say something like this, because both CL could be assigned to something of type I, and of course inf1 could, because it's already got type I. And that's what it had to be, basically. And the type of the expression there is the same as the type of inf1, which is I, of course, because you could say something like inf1 equals CL. You can assign, that's assigning something of type C to something of type I, and got something of type C and something of type I there, so the answer is the resulting expression is of type I, which is quite acceptable for inf2 because it's of type I. Simple enough, really easy. Right, well, in the next edition of the Java language specification, edition 3, lots of things were put in, like generics and boxing and all sorts of things like that. And also the ternary operator got changed a little bit to be a bit more comprehensive. And this is what happened. If you've got interface I, J, and K, and you've got class X that implements I and J, and class Y that implements I, J, and K, say, and you've got some variables X and Y like that, then you can say something like this: true equals X, or X. If true, then X, else Y, basically. You can say that, and it works. And the type of this can be set to something of type J. And the reason for that is because both X and Y implement the interface J. So it doesn't seem unreasonable that you could assign whatever the result of that expression was to something of type J, because it doesn't matter which of these end up getting chosen. They can both be cast to something of type J. So it's not an unreasonable thing to do. However, you'll notice, of course, that something of type X is not assignment compatible to something of type Y, because this class, of course, could have all sorts of fields and stuff in it that's not in this class, and vice versa. So these are not assignment compatible at all. But of course, they both implement I and J, so it's not unreasonable that you could do this. Of course, in the old days, what you do is, if under Java Language Spec Edition 2, you're operating in that environment, then you'd simply cast the thing to J. Cast each of these to J, and of course it works alright. Okay then, so what happened, of course, was Java version 5.0 included generics and various other things, and it also implemented JLS Edition 3. So everything that followed Java 5.0 does it this way. Before that, it would fail because it was doing it this way. And of course, this result of this ternary expression, of course, can be assigned to something of type I or J. So, of course, both of them implement I or J. I've used J in this case. I could have put I in. And what happens, of course, is if you look at the Java language spec, what it does, in fact, is it the type of this ternary expression has to be computed, and it's not a simple type. It's not either I or J. It's what's called it computes it actually as what's called the least upper bound of X and Y, the two types that are involved. And it turns out to be something which is called an intersection type, and it's written like that: I and J. And all this means is that it means it is a type which can be set to I, or it can be set to J. And if it can be set to I, of course, it can be set to anything which is a super type of I, and of course anything which is a supertype of J. And so that's what it is. It's called an intersection type. Intersection types in general are just strings of just collections of classes or interfaces with and in between them. That's what an intersection type is. Right, here's a little a warning here. It's a caveat. That's Latin for warning or something like that. Both the Sun reference compiler and the Eclipse system use what's called compound types, and to describe this here. And these give almost the same answer as the least upper bound, except a compound type is slightly different, because a compound type always has a class in it somewhere, even if it's object, as in fact it would be in this case. And so you might see it described as object and I and J if you're looking at error messages, because that's because the thing is computing a compound type. In fact, compound types aren't even mentioned in the Java language spec, so it's a bit it's not very good of it, is it? But that's what it's doing if you look at the compiler code. And what can I say about this? Well, of course, this object here is completely redundant, as you'll notice. You see, least upper bound. In fact, the reason it's called least is because it prunes a lot of this stuff away. A lot of this redundant stuff is pulled out. Because if you can set something to I is an interface. Anything that you set to I is going to be some sort of concrete class that you've done new on somewhere to actually hold something. So you can set it. You can set object. Something a type object can be set to it, because of course object is like a super type of I, and of course J as well. So this is completely redundant, but it's an intersection type, and it's the same type as that, so it doesn't really matter.